So this session is about managing Linux and Unix with System Center in a private cloud. My name is John Tekatala, and I'm a program manager with Microsoft.
I'm Chris Bash. I'm also a program manager at Microsoft.
I'd appreciate it if folks in the audience could turn off your cell phones. Thank you very much. Chris and I work in a group called OSTC, which is the Open Source Technology Center. We're a group within the Windows Server and System Center that focuses on Linux and Unix. So we're the group that does the Linux drivers in Hyper-V. And on the System Center side of things, we do the agents that go into Virtual Machine Manager, Configuration Manager, and Operations Manager. So we're sort of a center of excellence around Linux and Unix. And this presentation is, like I said, about Linux and Unix, focused on System Center. Chris and I will be taking turns. We will go back and forth. Chris will be talking about Virtual Machine Manager and Operations Manager, and I'll be talking about Configuration Manager. So from the session objectives, what we want to do is look at the big picture of Linux and Unix management in System Center. If you've been to other presentations, you've had deep dives into Virtual Machine Manager, Configuration Manager, and Operations Manager. These are sort of vertical deep dives and lots of sessions within these areas. This session is a horizontal slice. We're looking at these three areas of System Center, but from a Linux and Unix perspective. What we'd also like to do is talk about the new features that have come as part of System Center 2012 SP1 and introduce them to you. So as we go through, we will present some of the new capabilities in SP1. Key takeaways. With the new capabilities that we've got in Configuration Manager, we're prepared and ready to manage the full life cycle of a Linux instance. So within this session, we will go through the life cycle of Linux from the time it has started from VMM. Then we will manage it through Configuration Manager and monitor it through Operations Manager. So again, the full life cycle of Linux across the System Center spectrum. The second takeaway that I'd like you to take is the fact that we are working and improving our capabilities in the System Center suite to manage Linux and Unix. We are working on depth and breadth. When I say breadth, I'm talking about different operating systems and different distros. And Microsoft has fully embraced the fact that Linux and Unix is part of the heterogeneous environment, and we're fully committed at delivering these capabilities. So from an overview perspective, we've got a few slides that will talk about Linux and Unix management from a general perspective, and then we'll go into VMM and Linux, and then Configuration Manager Linux and Unix, as well as Operations Manager Linux and Unix. And we will have time at the end for questions. We've got a bunch of interesting demos. So the demo actually is going to walk through the life cycle. So as part of the presentation, we will interspace the presentation with demos and just walk through the life cycle across the three functions of System Center. So what is Microsoft's strategy for managing Linux and Unix in the heterogeneous environment? We believe in a unified management, a unified view across your operating systems and across the applications that come both from Microsoft and other vendors. We will use System Center as the primary interface for management. System Center components obviously run on Windows. For the Linux and Unix capabilities, we will have agents that run on the Linux and Unix systems. that communicate with the services in System Center. We will support core capabilities. We want to go after the core scenarios, and we will build the core capabilities. Okay? And we're talking about full-strength implementation. We're not looking at just being a checkbox. We do realize and are committed to delivering heterogeneous management. And we've started down this path, and we will continue to improve as we go along the way. Now, there will be some areas that may not be considered core, and we will work with partners to augment our capabilities in these areas. So again, we're focused on the core, and we'll bring in partners to work on other areas. So the focus on Linux and Unix management is really about servers. We're not going after the desktop. We're not going after the workstation that a user may have. We're really focused on the data center and servicing the servers that are in the data center. So if you look at the range in the infrastructure from traditional to virtualized, private cloud, and the public cloud, we've got the management capabilities within the enterprise, the traditional for across Linux and Unix. When I say Unix, I'm specifically referring to IBM's AIX, HP UX, and Solaris. The Linuxes encompass all the current popular models, and as things change, we will get on board with newer versions and newer distros. As we move from the traditional to virtualized, we can see the need to support both Unix and Linux. But once we move to the private cloud and move to the cloud space, we don't see the Unixes having a great share in the cloud, and we're not planning on delivering Unix management in the cloud. We want to facilitate you to move between these different infrastructures. So our job is to make sure that when you've got a Linux instance, you're able to move freely between these infrastructures, and we will provide you the management capabilities to help you. Chris?
Yeah, thanks, John. So John talked about our commitment to managing heterogeneous enterprises, managing Unix and Linux. I like this slide because it's the proof. So we started on this journey for heterogeneous management back in 2008 when we started developing Unix and Linux capabilities in Operations Manager. Since then, we've added all right, well, we still have the strobe effect, but we'll, at least we can talk.
Thank you all for your patience.
All right, so the point here is we started on this journey in 2008. We built on it. We added Java application server monitoring. With SP1, we added a Unix, Linux, and config manager, Linux capabilities, and virtual machine manager. So when we say we're committed to this, we're actually delivering on that. We're continuing to invest in these products and building both in our breadth of portfolio and then the capabilities within that portfolio. Supported operating systems. If you've been in any of our sessions over the past few years, you'll notice this list is getting bigger, primarily through the addition of CentOS, Ubuntu, Debian, Oracle Linux. Those are all available for monitoring in Operations Manager as of SP1. They are coming in Configuration Manager soon.
Due shortly, yes.
I've also added in System Center endpoint protection for Linux, that full breadth of Linux operating systems. And on Virtual Machine Manager, we'll get there once Hyper-V declares support for Debian and Oracle. And we're continuing to support in Operations Manager and Configuration Manager the big Unixes, AIX, HP UX, and Solaris. So the core of our Unix Linux management portfolio comes down to the three products John called out earlier. Operations Manager, it's how we monitor the operating system, log files, your Java applications, you monitor your production applications, databases, web servers, and we'll talk more about that. Configuration Manager, got inventory capabilities, reporting capabilities, software distribution, and then the endpoint protection for Linux is also part of the Configuration Manager component. And then Virtual Machine Manager, I'm sure you've heard a lot about it this week, allows us to deploy Linux and Windows VMs, specialize the operating system as we're deploying them, define multi-tier templates, and deploy multi-tier applications out of those templates, do scale out and live migrations across Hyper-V. So how many of you are using Virtual Machine Manager today? Good. Anyone tried deploying a Linux VM with Virtual Machine Manager SP1? Great, some, yeah. So this is brand new capability in SP1, available a few months ago. And what the scenarios here allows you, VMM, let me step back. VMM before SP1, you could manage the state of a Linux VM you were running on your hypervisors. You could power it on. You could do a snapshot. You could deploy a disk and then go in and manually configure it. What we've added in SP1 is the ability to deploy a Linux VM from a template to set key operating system configuration so that you're not sending out a bunch of VMs with the same host name and invalid network configuration. They have to be manually configured. With that capability, you unlock a whole lot of other features of VMM, the service templates, the scale out of service templates. So that's really the key element that was missing in VMM for Linux prior to SP1 and is now unblocked for Linux in SP1. And of course, it's fully integrated in the UI and the commandlets. Most of VMM is really operating system agnostic in terms of what's on the guest machine. So there's a very little divergence between working with a Linux VM in Virtual Machine Manager and working with a Windows VM. So I mentioned OS specialization. And this is in Windows, this is, if you're familiar with the unattend sysprep implementation in Windows, the Windows operating system is actually doing that OS specialization. So you take a generic image that's a sysprepped Windows image and deploy it, and unattend files given to the VM, and it configures host name and administrator credentials and networking. So we now have that capability in Linux. It's not done with sysprep and unattend.xml, but it's a very similar process. So you start with a VHD, or VHDX that has your Linux image installed, your Linux operating system installed. Has the Linux integration services for Hyper-V. Of course, many of the newer Linux operating systems have those integration services built into the kernel. And then we have a small agent prerequisite. It's actually a short-lived agent. It only lives through the deployment, and then it removes itself. And the VM template that is used for this consists of a hardware profile, which is completely operating system agnostic. And then the OS profile is where we have the one key divergence between a Windows VM and Linux VM. And we set properties like host name and DNS domain name to form the fully qualified domain name. We'll set the root password, and that can come from a run as account or be built into the template. We'll write a public SSH key to root's authorized keys, so you can set a SSH key off. Set the time zone, and then we'll explore the run once command lines in the demo, but that allows you to set an arbitrary set of commands to run during deployment. With that, let's get started on the demo. And John alluded to this, if the VPN holds out, and we hope it does, the scenario is that we're going to deploy a two-tier application. It's our Dinner Now accounting application. It's a PHP app running on Apache and MySQL database backend. We'll deploy a developer VM with Apache and MySQL, and then we'll pick it up throughout the session in other parts of the demo, link that into Configuration Manager and Ops Manager, and actually build out the management and monitoring of these VMs. So it's one continuous demo. To start with, we'll look in Virtual Machine Manager. And I have a virtual machine template here. And in the hardware configuration, this is just like for a Windows VM, we set memory. And if we scroll down, we can see that it's connected to one of my virtual machine networks. And then in OS configuration, let me zoom in on this, we have Linux-specific operating system OS profile. And you can go into the OS profile and select, I want to create a Linux OS profile or a Windows OS profile. And you'll see instead of setting administrator, we're setting root. Instead of setting Active Directory domain, we're setting a DNS domain name, those kind of differences. Now, these run once command lines I mentioned earlier are arbitrary commands that will run during deployment. There's some cool things you can do with that. You can, in this example, if any of you can read this, I'm actually mounting an NFS volume and then calling a set of installation scripts. So the VHD in this template is just a generic SUSE Linux 11 SP2 installation. I have no real apps on there. It's a very small base OS image. I have an NFS volume that I have an installation package for the configuration manager agent, an installation script that with a bunch of RPMs for MySQL, and an installation script and a bunch of RPMs for Apache. Those could be baked into the VHD, and we could call them there, or we could use Yum or Zipper or Aptitude and pull down packages from the internet as we go through this. Those commands will be run after the VM has been configured, but during deployment. So your network will be online, your host name will be set when those commands are actually run. Light is hypnotic. So, of course, App Controller is a self-service portal for Virtual Machine Manager. That template was my developer's template, so I can just go and select that. And in this case, I'm the developer operating within the restrictions that have been set by my administrator to access App Controller and deploy my dev VM. And I can just spin that out. It'll take about 5 minutes. And in the meantime, we can come back to service templates. So if you're not familiar with service templates build on VM templates and allow you to describe multi-tier applications. Some pretty cool capabilities like load balancer integration, so you can have a web tier that's automatically, as VMs come in and go out, your load balancers are configured if there's a VMM integration for them. You can also mix Linux and Windows in a service template. I've done demos before where I had an Apache front end and a SQL DAC database in a service template and pushed those out simultaneously. And in this case, we're all Linux because that's how we like it. And I've got a web tier and a database tier. And this is very similar to my developer template. But in this case, I'm going to also pull off that NFS volume, some actual application, a tar of my PHP files, and a MySQL backup that sets up my MySQL database. And so there are just a few more commands I threw in here to install MySQL. One thing I want to point out is that if I'm deploying a web server and a database server, the web server has to know how to connect to the database server. I don't want to hard code that. This is a template. So I can use a VMM service setting variable for my host name on the database server. And then if I come into the commands on my web tier, scroll over, you can see that I'm actually referencing that variable in my installation script. That'll write my connection in my con.php file that sets the connection string for the application. And I could set scale out on this maximum, minimum, default. So if I wanted 5 web servers to roll out when I push this out, I could set that there. So I'll go ahead and give this a name. It's my Dinner Now Accounting version 1. And I set that service setting to be mandatory, so I don't try to send out a null host name. And I'll go ahead and give it a database server name. Rerun placement, and deploy that out. So again, that's going to take about 5 minutes. We'll come back and actually, look at that application once it's deployed here. So to drill in just a little bit on how this works, I mentioned it's like unattend sysprep for Windows, and if you're familiar with that implementation, you'll see how very much like that it is. We start out, we have a VMM server with the library. We put our VHD with our Linux integration services and our small VMM Linux agent in that library. We create our templates in the library, and then when it goes time to deploy, the server is actually going to generate an XML file. It looks a lot like unattend.xml. And then create an ISO. It actually puts that document and also puts the latest version of our VMM Linux agent in case we've done any kind of update rollups and have a new agent to push out. You don't have to go and rebuild all your, crack open all your VHDs and put a new agent on there. Then the host creates the VM, virtual hardware is set up, the VHD is mounted as the disk, the ISO is mounted in the virtual DVD drive. Our VM boots up, and then the agent starts up, checks and sees if there's an upgrade available for it on the DVD drive. If so, it upgrades, and then it reads the configuration, runs through the configuration, and then shuts down the VM to signal VMM that it's done. And like sysprep, we do a little bit of sanitizing of the system. We'll flush any bash history files we can find. We'll delete persistent net rules for UDEV so that your network adapters start renumbering at 0. And try to do a little bit of that sanitization to make the Linux VM be a new instance, not a clone of an existing one. So one way we like to look at this, because Windows VM management and virtual machine manager is so well established, we can kind of compare and contrast what works for Linux, what doesn't work for Linux. And that should give you a pretty clear picture of what we have, what the story looks like for Linux. So live migration, placement, all that, doesn't really care about the operating system. We're all good. Host-based performance resource optimization. Again, it's talking to the host. That's all good. Scaling out Linux roles and services. In my web tier that I deployed, I can go back now in PowerShell or in the console and scale out that web tier within the confines that I set as minimum and maximum. All the networking configuration is good there. The Linux VMs don't have to be able to talk to the VMM server. It's all done offline through the host. And then storage management is good. Really no OS dependencies there. Everything in VMM, of course, is scriptable with PowerShell. That's true for Linux. We've gone in and modified some of the commandlets around templates and OS profiles and VM template deployments to facilitate those new Linux parameter sets. So there are a few limitations. This is brand new functionality in Virtual Machine Manager. At this point, we're only specializing a Linux VM from template to a Hyper-V hypervisor. So you can deploy a VMware template to ESX with Virtual Machine Manager, and similarly with Citrix Zen. That capability is not available for Linux at this point. It's VMM and Hyper-V stack where we added that capability. P2V conversion, we don't have an in-the-box story. There are partners that do P2V around Linux. We don't have an option there at this point. You'll notice in my demo, I was using those run once commands to pull scripts and RPM packages off of an NFS mount. I mentioned going out to the internet through a repository or baking those into the VHDs. We don't have an app profile for Linux. So Virtual Machine Manager does some really awesome stuff with service templates and app profiles for SQL DAC and MS Deploy and Server App B. Those are very Windows-centric application technologies. So we don't have an app profile for Linux at this point. So servicing of your service templates, if you're familiar with that concept in Virtual Machine Manager. Linux, you can do image-based servicing. You can go update that VHD that's part of a template that has been deployed, and then in servicing, push out that new VHD. That's a data-destructive operation. It's going to rip and replace the VMs you've already deployed and rerun through the configuration. There are scenarios where that's a good thing. If you have a web tier that has no data, no state, and you just want to be able to roll out a new operating system version, that's great. But it's not going to be able to do the robust servicing around preserving state and data that's available for technologies like Server App B and SQL DAC. And we don't have a pro-tip implementation into the guest. Our pro-tip support stops with the host. With that, we'll move on to Configuration Manager, and we'll pick up later in the demo the output of those template deployments. Thanks, John.
Thanks, Chris. So we're moving from Virtual Machine Manager to Configuration Manager. Wanted to start off by talking about the features that we do support, Configuration Manager features in Unix and Linux. As most of you may know, Configuration Manager for Windows has been around for a while, almost close to 20 years. This is our first release of configuration management for Linux and Unix. We're really focused on server scenarios. Okay, so a lot of the capabilities in Config Manager around client support with UI do not apply. And in a lot of cases, in the case of servers, Linux servers, because of the virtualization that has come to play now, some of the functionality in Configuration Manager doesn't quite apply as it would have, say, 10 years ago. So let's look at the list. We've really focused on core capabilities. We've gone after hardware inventory, the ability to figure out what you've got on the Linux machine from a hardware device perspective. Installed software, the RPMs or the PKGs that are part of the Linux installation or that are installed on Linux, we want to be able to pull that across and show that as part of the old add-remove programs that is available. It's now called installed applications. The ability to deploy software. Key capability here, new software, new packages, update your packages as well. Providing secure and authenticated communications, and reporting that is integrated with Configuration Manager. So your reports would span both your Windows and Unix Linux devices. We don't have push install for the native client, and part of the reason for that is there's other ways to do it. You can do it through scripts. You can use System Center Orchestrator to actually push install the client. So that's an option that's available to you. OS deployment to bare metal, not as important as it used to be, given all the virtualization that's out there. User-centric software, in the case of servers, didn't see that as a core scenario, so we're not supporting that. Desired configuration management or settings management. Now, that's an area we would have loved to have some provided functionality. We haven't gotten that in this release. Patch management, sort of similar to what you've got with Windows and WSUS. We do not have that capability. You can use software deployment to install patches, but an integrated way to do this, so integrated patch management, we don't have that capability. Internet-based client management, since these are servers within the data center, didn't see the need to support that either. So let's take a look at the architecture of our implementation. So the big box at the bottom is the Unix Linux client, and what we've got is the client. We've implemented CCM exec. So those of you who are familiar with Configuration Manager for Windows, we've got an equivalent client on Unix and Linux called CCM exec. It talks to the config manager server roles natively. So we're talking to the management point and distribution point and also to the FSP using native communications, just like the Windows client does. Of course, there is no WMI in the Unix Linux world. So we have a SIM server. This provides a DMTF standards-based compliance. And I've got a slide that will talk more about the SIM server. But the model is you've really got providers, pluggable providers, and we've developed a bunch of core providers that we provide as part of the install. All the boxes that are in white is code that we've developed that is common to all our platforms and distros. And we've got an abstraction layer called the platform abstraction layer, that's the one in orange, that directly accesses the resources of the OS. So this way, we've got common code across all our platforms and abstracted out OS-specific stuff into one layer. So what are the hardware inventory scenarios? If you're familiar with Configuration Manager, you know you can use Resource Explorer. We support that. Since our data goes into the same tables that Windows uses, the Windows data goes into, Resource Explorer works great across that. And as part of the demo, I'll show you that. You can view the installed software. So if it is Linux, if it is, you can look at the RPMs, for example, on SUSE. If you are looking at Solaris, you can look at all the PKGs that are installed. You can create collections, standard, configuration manager capability, the ability to use hardware inventory to create your collections and then target those collections for things like software distribution. You can run reports across your enterprise, across your organization. Now that you've got your Unix and Linux inventory in your database, in the same tables, your reporting works across the board. So let's talk a little bit about how we implemented hardware inventory. The SIM server that we're using is actually called OMI, or Open Management Infrastructure. This was developed by Microsoft. The Windows Server team has been responsible for most of that development. This has been open sourced through the Open Group. So if you're interested in understanding how this SIM server works, you actually can get the source code for that. The Linux and Unix classes that we've implemented map to the Windows classes. So, for example, Win32 operating system is a Windows class. We've mapped it to a Unix Linux equivalent so that classes and properties are one-to-one mapping, so we can actually populate the tables with our data, and it all works across the board. We've only implemented a subset of all the Windows classes that are out there. We've focused on core capabilities, and we do have the ability for you to extend that should you need to. And I've got a slide on extension of that. As far as hardware inventory goes, we support the same capabilities that Windows has, which is first time it connects or registers, it will send up a full hardware inventory, and subsequent ones are deltas. So you're not using up your bandwidth by sending full hardware inventory every time. So there's a story around extensibility of hardware inventory. The SIM server has got pluggable modules. Custom providers can be created by you. So all the information you need to create your own provider is available on the open source website, or the Open Group website, rather. So the project is called OMI, or Open Management Infrastructure, and it's open source through the Open Group. Everything is made available to you. You can create your own providers. But the model is you create your provider, and you plug it in and register it with the SIM server, and it's available to collect your own proprietary inventory. And that inventory, you import the MOF file into your config manager UI, and you've got an end-to-end capability around custom hardware inventory. Of course, your new providers would have to be installed on each client. You can use software distribution to do that. So software deployment, that's the other major scenario that we support. You can obviously deploy applications. You can deploy patches to the installed applications. You can also deploy OS patches. Again, over here, we're not supporting patch management. If the admin or you as the admin know which patch needs to be applied, you can download that patch, have that available on your config manager server, and then use software distribution to push install this to a collection of Linux servers. And that collection could be a very targeted collection based on inventory properties. So you could use the software inventory versioning to determine the collection that needs to be updated, and then apply this software distribution, apply the patch through software distribution. You also have the ability to run arbitrary maintenance scripts. And the way this works is that software deployment has got two constructs. There's program and package. So if you do not have a package, you can actually just run a program. And you can run this on a collection of Linux machines. So essentially using software deployment capabilities to run arbitrary maintenance scripts on a collection or group of computers. So let's talk of the implementation here. So if you're familiar with Config Manager, you know the IT admin, the admin UI, site server and database, the management point and distribution point. When the IT admin wants to deploy software to a bunch of Windows clients, they create a software deployment, define a package, which is typically an MSI, and a program, which is oftentimes MSI exec, and then advertise it to a collection of Windows clients. Periodically, the client on Windows will wake up, download the policy, figure out what needs to happen, go to the distribution point, download the package, and during the maintenance window, run the installation and report status back. Okay, so this is standard. It's been around for some time. This is how Windows works. What we're saying is we're bringing our Unix and Linux servers into this mix. So how does this all work? Well, guess what? There is no real difference. The IT admin creates a software deployment and defines a package. But in this case, instead of defining an MSI, he or she specifies a PKG or an RPM. And instead of specifying MSI exec, for example, they may specify the RPM command, so RPM IV and package name. The IT admin then advertises this software distribution to a collection of Unix or Linux servers. And CCM exec, our agent on Unix or Linux server, wakes up, pulls the policy, downloads policy, acts on it. It goes to the distribution point, downloads a package. Now, in our case, we're only supporting HTTP or HTTPS. We're not supporting SMB. Okay. Again, we respect the maintenance windows, and we will deploy and report status message back. Okay. So essentially what we're saying is the Unix and Linux capabilities that we've got for software deployment dovetails with the existing functionality. All right? So the IT admin has got a paradigm that they're used to and the UI that they're familiar with. We've got no UI in Config Manager that is specific to Unix and Linux. Okay? The UI is generic enough for us to be able to use software deployment and all the other capabilities across the board for all the platforms. Okay, we use existing hardware infrastructure. No need for additional hardware, no need to define new site roles. It's all part and parcel of what you've got there. And most importantly, from an IT admin's perspective, management paradigms remain the same. They don't need to learn a new paradigm for managing their Unix and Linux servers. Okay? The one that they're familiar with for managing Windows works for Unix and Linux. All right, with that, let's switch to a demo on Unix and Linux capabilities. Okay, so those of you familiar with Config Manager 2012 SP1 know that this is the console. We've got 4 areas: assets and compliance, software library, and monitoring. We're sort of going to go through these. We're going to go through the first 3 and not go into administration. So let's look at devices and see what we've got there. Okay, typically in the past, you had only Windows computers show up here, and a few additional devices. But now you've got a suite of Linux and UNIX OSs showing up here. I've got an HP UX. I've got a SLES, a SUSE. I've got a Sun OS Spark installed. And I've got a Red Hat and an AIX and a Debian. So lots of new platforms that are registered here.
Attention, please. The alarm you have just heard is part of the hotel early alert system. The reason for the alarm is now being investigated. We will keep you advised. Thank you. May I have your attention, please? The alarm you heard was caused by a minor...
Sorry, guys.
The situation has been taken
Out of my
care
control.
We apologize for any inconvenience. Thank you.
You're welcome.
May I have your attention, please? The alarm you heard was caused by a minor incident. The situation has been taken care of. We apologize for any inconvenience. Thank you.
Okay. All right. Oh, no. Is that going to go on?
I think we're clear.
All right, we're good. We can continue. Now, you guys don't have this thing flashing in your eyes like I've got, so you're doing better than I am. All right, so if you recall from Chris's demo, he had the run once command, and those of you who actually looked at all the things that were in there may have noticed that he actually had the installation of the config manager client. And so you're seeing a couple of instances of Linux that were actually part of what Chris kicked off, and I'm just going to go ahead and approve these clients. The network is slower. All right, I can go ahead and approve this. All right, so once they're approved, they can now go ahead and get policy, from the management point and start acting on the policy, upload hardware inventory, the software distribution, work on that. Okay, so what I'm going to do for this demo is not wait for all that to happen. I'm just going to walk through an existing instance. So I'm just going to run launch Resource Explorer on this and give you a look at the hardware inventory properties. So these are the classes that we've implemented. We've gone after core functionality. You've got information on your disks. You've got information on your installed applications, on the network. So let's just walk through what we've got over here. So this is disk drives, disk partitions, installed applications. These are all the RPMs that are installed. And if you notice, you also have things like version information as well. Logical disk, good information there. We've got information on free disk space, for example, number of blocks, volume name, network adapter. If I click on that, you've got information on your MAC address and network address. Status OK. If it wasn't OK, we wouldn't see this. Network adapter configuration, information on the OS itself. So this is information that's reported. Includes kernel information, OS architecture, number of processes that are running, and there's also information on total swap space, virtual memory, and visible memory. So lots of core information here. Processes will show you all your running processes. Services will show you all the daemons that are running. In the Unix Linux world, they're called daemons. So a ton of good information around hardware inventory. You've got similar information on on Solaris as well, or IBM AIX. So the next thing I'm going to do is sort of walk you through software distribution. So I've got Java for SLES defined here. And if you look at what it actually consists of, the data source, I have the data. The Java package is actually on my config manager server. It's in a seed folder, C directory, C Java, Java 1.6. If I look at the program that I now run on this, you can see it is actually the RPM command, RPM IV, and the name of the Java package. If I look at requirements, you can see that we've actually enabled all the new platforms here. So I'm targeting this specifically at SLES 11. So if my collection is really broad, and this package goes down to a non-SLES 11 x64 machine, it will not run it on that one simply because it is targeted very specifically. All right, so what I'm going to do now is actually just go ahead and deploy this. And I'm just going to pick a collection of SLES computers. I've got 2 SLES computers here in my collection. Click on Next. The distribution point has already been identified. I'm going to say the purpose is required. You don't really have an option here because we don't have any UI in our implementation, and the expectation is that all packages are required. Again, these are server scenarios. I'm going to go for an immediate deployment. And there's really no user experience, so all the settings on user experience get ignored. And choose the defaults here. And that's pretty much does my deployment. So I've configured it now to deploy to a collection of SLES computers. So let me switch to the SLES machine itself and show you what we've got here. If I do PS, I can look at all the running processes. And you can see my 2 CCM exec running as well as the SIM server. Those are my 2 processes. What I'm going to do is I want to get the software to deploy right away. So rather than wait for the client to wake up and do its thing, what I'm going to do is actually get it to wake the client up and force it to do a software a policy download. Okay, so this should actually wake the client up, and have it download the policy, and the policy should be interpreted, and software deployment should work. So I'm installing Java, and just to confirm, if I do Java ? I don't find the Java application. So if my deployment is successful and I do this, I should see a help screen show up. So while this is going on in the background, I'm going to switch to reporting and show you some of the reporting capabilities that we've got. So a very common report is count of operating systems. Now this was the report that shipped with Configuration Manager. There were no changes. These are the canned reports that ship. And as you can see, it is actually pulling up all the additional Unix and Linux systems as well. So if you're a CIO and you want to know about all the machines within your organization, a consolidated report like this brings in all the Windows machines as well as your Unix and Linux machines. The second report that I want to show you is count of instances of software that is registered. And I'm going to pick the collection. I'm going to pick all SLES x64 computers. Okay. Let me try OK again. No, this is not a good sign. If the network is frozen on me. Okay, there we go. All right, so what I'm now doing is I'm pulling up all the RPMs that are installed in this collection. Okay, so across all my computers in this collection, I'm looking at all the RPMs. So you can see there's differences in count on this particular package. So I've got two instances in my collection, and in this case, I've got different versions of SCX. This is actually the Operations Manager client. So you can see the differences show up. If I'm looking for OpenSSL, for example, if I'm concerned about the security of my machines and whether or not they've got the latest version of OpenSSL, you can actually check and see whether this collection of SLES x64 computers has got the latest version of OpenSSL. So a consolidated view of all the RPMs within a collection, all part of the report that ships, part and parcel of what ships with Configuration Manager. All right, so let me go back and see what's going on with my Java install here. And let's see if I type the Java question mark now, I get the command, the help command, and which tells me, hey, Java has indeed successfully installed. And obviously, if I go back into the Config Manager console and look at status of the installation of the software deployment, it's going to show up as success. So that was the demo, and we will switch back to the presentation.
All right, let's do a little unscientific polling. How many of you are using Ops Manager for Unix or Linux today? All right, how many of you are here because you're thinking about using Ops Manager for Unix, Linux? That's a nice split. All right, great. So this will be new for some of you. So Ops Manager, of course, is our dear friend who does all the monitoring in System Center. What we do for Unix and Linux is really out of the box implementing core operating system monitoring. Gives you good coverage of your operating system and system health, and then building a platform that allows you to go on and monitor your applications and your higher level stack. We have in our management packs diagnostic and recovery tasks where appropriate. So if your cron D daemon is down, we'll do a diagnostic that runs a PS command and give you an option if you've set up the run as profiles to do a restart in a recovery task. We have management pack templates for building out custom monitoring and tasks, and we'll go through that in a demo. Of course, reporting. In 2012, we added completely revamped our reporting to add about 12 reports per operating system that are a little more relevant for Unix and Linux than what we had in 2007 R2. Of course, we have audit collection service extended to Unix and Linux, where we forward syslog security events into audit collection services instead of Windows security events. And all the agent administration is centralized through both the Ops console and then PowerShell. So that's our feature for Unix and Linux in a very high overview. I do want to make sure we have time to get to the demo, so I'm moving a little fast through this. The Ops Manager architecture, and if you're using Ops Manager today for Windows and you're looking at doing it for Unix and using it for Unix and Linux, there's a fundamental architectural difference. If you grab me after the session, I'd be glad to go all into depth about why. But a Windows agent in Ops Manager has its own health service, has its own local database. It pulls down management packs from the management server, runs its rules and monitors locally, pushes data back. For Unix and Linux, the architecture is flipped. We have a lightweight agent on the Unix and Linux agent, and we use a lot of the processing of the management server's health service. So one way to look at this, I think, provides a good illustration is to actually look at the communication channels between the management server and the Unix and Linux agent. And the first one we should call out is SSH. So we do have a secure shell implementation that allows you to do agent administration from the Ops Manager console. And this communication is actually via the from the management server to the Unix and Linux computer, even though the activities are invoked by the console or PowerShell. And we only use this for agent administration. It's only used when you go as an admin and do something. We don't use SSH for any monitoring, so if there are restrictions around SSH and that you don't want to use it and you have another mechanism for automated software deployment, by all means, you don't have to use SSH. But this is how we do an agent installation from the console, how we do an agent upgrade, how we do an agent uninstall, how we do an agent restart if it's down. And we support SSH key auth, we support over SSH, we support SU elevation as well as sudo elevation. But really that's about the managing the agent installation. Everything else, all the monitoring, all the ongoing tasks are over a protocol called Web Service Management, or WSMAN. And this is a standard open protocol. It's a SOAP-based web service protocol that implements the DMTF SIM standard over a XML web service. And again, this is communication coming from the management server to the Unix and Linux agent. We're actually using an open-sourced SIM server on the other end, on the Unix-Linux side, called OpenPegasus. We've been active in that community and contributed some fixes back to OpenPegasus. But that is an open-source product, and then what we've done is gone and built all of the provider implementation. Without getting into too much detail on the providers. Providers are what do all the work. We're going out. Our providers are how we know what the CPU use is on a system, what the processes are, what processes are running, how we run a command, things like that. And these are all, the out-of-the-box implementation is all done through native kernel interfaces. We probioctals to get the health of a network interface. We're going to kstat to get performance statistics on Solaris. We're going to procfs on Linux and perfstat on AIX. So together, the OpenPegasus SIM server and our providers, which we've also open sourced, make that Unix and Linux agent. So the key difference here is the management server is actually doing the scheduling of each rule and monitor and then doing the processing of the data. It's going out and getting the data from the Unix Linux computer as needed for each rule and monitor. If you're familiar with cookdown, we've highly cookdown optimized those. And so it is a different implementation than Windows. The net result, though, is it's a very lightweight agent. It's completely, the whole agent is completely open sourced. You could go build it from source if you want. Probably not necessary, but you can do that. It's lightweight, it's highly portable. We build this across a matrix of, I think, 27 different operating system and processor architecture combinations every time we check in a piece of code. So, out of the box, I mentioned earlier that we're shipping management packs that cover the operating system, and I feel pretty good about that statement. In terms of the health of the operating system, I feel that what we're delivering in the base management packs that come on the media or you download updates from the Microsoft Download Center, we're doing a good job getting health of the operating system, the CPU health, performance collection, and alerting, memory, disk, both physical and file system. We're collecting network statistics. We monitor a set of default daemons out of the box. There's a wizard we'll walk through in the demo for very easily monitoring additional daemons. We monitor for some common security events in syslog. Again, there's a management pack authoring wizard for adding additional custom log file monitoring. And these templates, so again, we've custom log file monitoring. We just go to the authoring pane, launch the management pack template for Unix Linux log file, specify log file in a regular expression, target a group of computers. It's that simple. Same with process monitoring. Walk through a similar template, select a group or an individual computer, and let you browse out and see a list of running processes if you don't know the exact process name. You can distinguish multiple processes with the same name based on the arguments. So if you have 10 apps all with the process name Java, but they're individual apps, you can use the arguments, argv1 through argvmax, to filter that. And then specify minimum, maximum counts for process monitoring. And then probably the most extensible in the console experience are our shell command templates. You can build 2-state and 3-state monitors, performance collection rules, and alerting rules, as well as agent tasks that run a shell command or call a script from within the console itself. So those aren't management pack templates, but those are in the authoring pane of the ops console. You can go create a new monitor, create a new rule, and select Unix, Linux, shell command, and put in your command. It can be a one-liner, it can be calling a script you have in the file system, and then you can build your expressions to parse the standard out or standard error to drive your monitor or rule. And we'll look at that in the demo. All right, so in terms of monitoring applications, we can, for some basic scenarios, we can go through the templates, call our scripts to monitor our applications. It's a good approach if you have custom developed applications. For the common off-the-shelf applications, we've got a good partner representation. See some partners in the room here today, and partners are very well represented at the expo hall. So if you want to monitor Oracle or DB2, Domino, got good partner coverage on that. I'd suggest you walk through the expo hall and talk to some of these partners. eView is doing AS400 extensions, and of course, I'm sure most of you are familiar with what Veeam is doing around VMware ESX monitoring. In terms of what's new in SP1, we did add, this is we went from supporting Red Hat and SUSE in the Linux space to adding CentOS and Debian, Ubuntu, and Oracle. That was our big investment of time and features in SP1. We've improved our heartbeat monitoring. We got a lot of requests around, I don't want a heartbeat alert every time I reboot the box. So that's now a configurable setting. We fixed an issue that was preventing the network vicinity dashboard from working for Unix and Linux computers. And we've improved the shell command templates. So we're continuing to mature the product, build on our implementation. And with that, I would like to jump into our demo to complete out our scenario. So quickly wrapping up on what we did with VMM. Our VMs are now deployed. Our service that I deployed earlier is now there. With any luck, our website will be online. And this was the website that was pulled from the NFS share as a tar file installed with the Apache server, and it's connecting to the MySQL database on the other VM. So that was completely deployed during that VM service template deployment. And of course, since I have Ops Manager wired up to VMM, I automatically get that service template modeled in Ops Manager. I don't think this has had time to discover yet. And while we were waiting, had a little magic going on behind the scenes. If an orchestrator runbook that's running a PowerShell script to get all my Linux VMs out of VMM that belong to my cloud, and then goes to Ops Manager, enumerates all Linux machines discovered in Ops Manager, does a comparison, and then determines that, takes that delta and kicks off a discovery. So while John was covering Config Manager, we have all our Linux VMs from the beginning of the demo now discovered in Operations Manager. And of course, in Operations Manager, we have we can go into the Health Explorer and look at what we're monitoring with the base management packs in terms of performance. So here we have our operating system stats for performance that are being monitored, memory swap, some processor metrics. And then, of course, under availability, we have our daemon health, processes like cron D and ACPI. We have our logical disk, our file systems. We're monitoring things like inodes and free space. And our physical disk, we're monitoring transfer time. And then, of course, we have a pretty broad selection of performance metrics that are collected by default. So if I wanted to look at, say, swap metrics on a box, say used and available swap for my Red Hat server here. Catch up. All right, I was thinking about it. All right, so in the sake of time, I'm going to go ahead and jump into our customization, because we've now deployed a MySQL and Apache-based application, and we're monitoring the operating system, but we're not actually monitoring MySQL and Apache. If I wanted to do some basic monitoring there, I could simply come into the authoring pane, launch the management pack templates, and I'm going to walk through and start monitoring MySQL D. So before the demo, I actually set up a dynamic group that's populated based on the host name. So any host name that has an lnx-db, I assume to be a database server. So I can select my lnx-db server that we deployed earlier in the template, from the VM template, select the MySQL D daemon, and I'll go ahead and target this to the group. And here, if you can see in the bottom, this is where we could optionally go in and put a regular expression against those process arguments if we had multiple MySQL D processes and we wanted to evaluate the health of just one of them. And I expect one of these to be running, so I'll just set a minimum threshold of 1. And now if MySQL D goes down, we'll get an alert that tells us that the process isn't running in what machine. It's pretty straightforward. That's a good start. You know, if MySQL D is not running, then MySQL's got a problem. But it's not the end of the story for monitoring. We can certainly go in with, say, a MySQL command line, run the show stats query, and get some performance statistics. So I could take that kind of query, filter that with a grep for, say, if I can type correctly, say threads connected, awk that to get just the second value, and take that, sing that straight command and put it into a shell command wizard for performance collection. Likewise, I can take this same MySQL query and grep that for error, which will pipe it to wc-l, which will give me a line count. So if I don't see the string error when I run my MySQL query, then I get a value of 0. If I were to stop MySQL, run that command, I get a 1. So 0 is healthy, 1's unhealthy. I can simply take that command, copy it, go into create monitors under authoring, create a new unit monitor, I'll create a Unix Linux shell command 2-state monitor. It's either up or not up. And I can actually target this now to the MySQL daemon that was discovered as part of the process monitoring. So I targeted my process monitor to a group that defines a new class type for that process. And on each computer, that's an instance on each computer that's part of that group. And I can actually use that for class targeting in these templates. And that's a little simpler than going in and targeting a Unix computer, disabling it by default, and then overriding it for a group. Because I already have that group processing on the MySQL daemon class discovery now. I can just target that class and not have to worry about disable, come back and override to enable. So I'll set an interval of 5 minutes, paste my command straight in there, and if I recall, said that standard out equals 0 is 1 is unhealthy, and standard out equals 0 is healthy. And that's a critical condition, and I can simply type in my alert message. So MySQL query failed on host. Bring in my target computer name, and then just for troubleshooting, I'll bring in all the output data. So that'll be standard out and standard error. And then that's all it takes to build out. I could go in with additional commands like that and kind of build out further monitoring. And then I can go into create a dashboard, dashboard out using the groups and the classes that we discovered in the console, create a dashboard with perf views and alert views and log views. So I know we're running up against time. We've had a few interruptions, some excitement this morning. But again, what we really wanted to present today was this broader overview of this big picture scenario, start to end, of Unix and Linux management with System Center, and expose some of those new features in Config Manager and Virtual Machine Manager as we went along. So again, we're really talking now for the first time, we're not just monitoring, we're talking about deployment, we're talking about ongoing configuration management, really the full management suite for Unix and Linux. And then the last takeaway is that we're serious about this. John and I and our dev and test teams work on Unix, Linux every day. This is what we're there for. We want to see you using it. We want to hear your feedback and keep building on this. All right, well, and make sure you do your evaluations. There will be a test. I don't know how we're doing on time for questions. For the next session, I'm sure we could do something offline if.
Well, we'll take a few and see if we get thrown out.
Yeah.
So, pretty impressive. Any possibility of adding support in VPN for backup?
So we definitely recognize that there's a gap there, and it's certainly on our radar. As far as any announcements, you'll have to stay tuned. But we definitely do see that as a gap in the System Center portfolio for Linux, and we're going out after those gaps. So, yeah.
What portions did not work with the Echo project to deploy the OS?
I'm sorry, I didn't hear.
Was it just the deployment of the OS that did not work with the Echo? What about the rest of the
Did you get that?
No, I didn't. Could you come up or step to the mic, please?
Yeah.
Thank you.
There's a question over here.
Yeah, there's a talk in that session about
Agent caching as far as yeah, so, and that's that's certainly a trade-off of the lightweight approach we've taken, and we do get that question brought up frequently. We don't really have plans to do that. The approach we've taken is really this kind of lightweight, open, standards-based stack. When we talk about caching, in Ops Manager, it gets to be a little more proprietary, and so It's not on our horizon at this point, but we do get a lot of feedback about that.
Yep.